So procedure of PCP. So consider two lists in the form of F and S. These F1 shown up to Fn represents the elements of F. S1, S2 shown up to Sn represents the element of S. So for each I, the pair Fi, Si is said to be the correspondence pair. So we need to find the sequence I1, I2, I3 and Ik. Basically this will let you know about the in which way you are going to use your dominoes, right? So this is that sequence. So with k greater than equal to 1 such that F1, F2, F3 shown up to Fn is equals to S1, S2, S3 shown up to Sn. That is, this is your numerator and this is your denominator. You will have to make both the strings equal. So then you can say that the sequence I1, I2, Ik shown up to Ik is the solution of PCP. So note that you have to suppose the value of k greater than n, where n is the element count in list. That is, k is equals to n plus 1. So let's take an example. So in this example we have two lists in the form of F and S. First of all, you need to put all the elements of F and S in the form of table, right? After the arrangement, you need to suppose the value of k. So here the value of k is equals to 4 because n plus 1 and the count of elements is 3. So value of n is equals to 3. 3 plus 1 is equals to 4, right? So k is equals to 4. Then you have to find out the sequence I1, I2, I3, I4. This is basically arrangement. That is, which domino will be used first. So I1 is equals to 1 means first domino will be used first, then second domino, then third domino, then again second domino and then third domino. So the solution is sequence is 1, 2, 2, 3, right? So we can verify that whether this list is the solution for the given PCP by concatenating the corresponding strings in order for the two lists. So we have, so first of all, I1 is equals to 1, which means you have to use F1 and S1 at the first position. That is, you need to use this domino. So place 1, 0, 1 cube at left hand side and 1, 0 at right hand side, right? After that, the I2 is equals to 2. That is, you need to use this 1 F2 and 1 cube S2. Then again F2 will be repeated. That is, again you need to place 1 and 1 cube. And final is I4 is equals to 3. That is, this third domino will be used, right? So we have 1, 2, 3 and 4. That is the reason we have used k is equals to 4. That is, at the value of k you will find the same sequence of strings at left hand side and right hand side. So thus this PCP has a solution. Second example. So prove that the PCP with two lists F is equals to BA, A, S is equals to BA square, AB, A square has no solution. So you can see clearly that all the elements of F are shorter, smaller than as compared to the elements of S. So the solution is each substring of list S is greater than each substring of list F. That is, Fi is less than Si for all I. Hence, the string generated by the sequence of substrings of F is always shorter than the strings generated by the sequence of substrings of S. Therefore, this PCP has no solution, right? Because all these elements are greater. Here you have 2 elements. Here you have 3 elements. 1 element, 2 element. So this is greater. So in this case, you can't find the solution. That is why this is called undecidable problem. So these are the possibilities where you can't get your solution. So the first one is unequal elements in the list. For example, F is having 3 elements and S is having 4 elements. So you can't get solution in this case. The second possibility is each element of S is greater than each element of S. Just we have discussed this example, right? And the last possibility is occurrence of infinite loop. So this is about PCP. Thank you.